L'Hopital's rule. Okay, L'Hopital's rule for form 0 over 0. Let A be any real number and f and g be functions such that f prime x and g prime x exist for all x except possibly at x equals to a and g prime x not equals to 0. Second, limit x approach to a, fx equals to 0 and limit x approach to a, gx equals to 0. Okay, next, limit x approach to a, f prime x over g prime x equals to L. L is a real number, infinity or negative infinity. Then limit x approach to a, fx over gx equals to L. So this is definition of L'Hopital's rule. Okay, ingat je formula ni. Senang je, differentiate fx, differentiate gx. So fx over gx, kita akan dapat 0 over 0, and then differentiate f over differentiate g. Substitute x equals to a, we get L. So L is real number, infinity or negative infinity. Okay, so faham Okay, we go to example Example 1. Limit x approach to 1, x square minus 1 over x minus 1. If you substitute x equals to 1, we get 0 over 0. Okay, this 0 over 0 kan mesti tunjuk mesti tunjuk. You must show because this have a mark, ada markah. So apa nak buat? Okay, kita ikut je definition. Limit x approach to 1, x square minus 1 over x minus 1 so equals to limit x approach to 1 to x over 1. To x differentiate x square. Okay, differentiate x we get 1. So substitute x equals to 1, we get 2. 2 is a L. Okay, so same as example 2. Limit x approach to 0 from right, sin 3x over x. If you substitute 0 into x, we get 0 over 0. And then differentiate sin 3x, we get 3 cos 3x, differentiate x, we get 1. So substitute again, x equals to 0, we get 3, cos 0, 1. Okay, for example 3, limit x approach to 0, 1 minus cos bx over x square. B is constant. If you substitute x equal to 0, we get 0 over 0. So differentiate 1 minus cos bx, we get b sin bx, x square 2x. Substitute again 0 over 0. So another again, sekali lagi awak kena differentiate atas, differentiate bawah. So b square cos bx over 2. Substitute 0 and we get b square over 2. Okay, so for example 4 sama jugalah. Example 4, 0 over 0 and then differentiate, substitute 0 over 0, differentiate lagi. Okay, so example 5, example 6, differentiate ni, differentiate macam biasa. So kalau awak tengok example 6, x negative 2, differentiate negative 2 minus 1, negative 2 darab, jadi darab. So yang ni simplify. 1 x negative 2 dia transform transform dulu. Okay, dia transform dulu. Dia transform 1 over x square sin 1 over x. And then dia differentiate. Okay, we get 2 over x cube negative. Okay, yang ni differentiate sin 1 minus 1 over x. Okay, so substitute 0 over 1. 0 over 1, we get 0. Okay. So next, indeterminate form infinity over infinity. Okay, so definition, if limit x approach to a, fx equals to infinity, and limit x approach to a, gx equals to infinity. Okay, limit x approach to a, f prime x over g prime x equals to L. Then limit x approach to a, fx over gx equals to L. So sama jugalah macam tadi, example 7, limit x approach to infinity, substitute infinity into x, so we get infinity over infinity. Apa nak buat? Differentiate atas, differentiate bawah. 4 over 5. Okay, example 8, so when you substitute x equals to infinity, infinity over infinity, and then differentiate. So bila awak differentiate, we get infinity over infinity. Again you differentiate, sekali lagi, differentiate sekali lagi. 10x, 10, 6x square, 6x. Substitute, we get 0. Okay. So for example 10, example 10, we use formula. Okay, this is a formula. Limit x approach to infinity xn over exponent x. Limit x approach to infinity n factorial over exponent x. Okay, n factorial is a real number. Exponent x, exponent infinity, we get infinity. Okay, nampak tak? Tak nampak. Okay, kesok sikit. We get infinity. Exponent infinity, we get infinity. So real number over infinity, we get 0. Okay, remember this. Real number over infinity, we get 0. For example 11, we use this formula. Terbalik je. Okay, limit x approach to infinity, exponent x over xn. So bila awak differentiate ni, kita dapat exponent x over n factorial. Exponent infinity, we get infinity. Infinity over real number, infinity. Okay, so infinity. Okay, next revision. Okay, awak boleh buat sendirilah. Sama je, differentiate atas, differentiate bawah. Okay, 0 over 0. 0 over 0 ni awak mesti kena tunjuk dulu. Okay, kemudian differentiate. Differentiate atas, differentiate bawah. Kalau awak dapat 0 over 0, differentiate sekali lagi. Okay. So tutorial 18. Okay, tutorial 18. Okay, saya dah buat sikit-sikit lah. Saya dah letak dalam MOOC. Awak tengok je lah dalam tu. Okay. So next, ada soalan? Okay. We proceed to indeterminate form. Okay, nampak tak? Indeterminate form. Okay, type 0 times infinity, infinity minus infinity. So example 1, limit x approach to infinity, x exponent negative 3x. Okay, if you substitute x equals to infinity, we get infinity times 0. So we transform. First transform dulu. Okay, exponent negative 3x ni bawa ke bawah. So x over exponent 3x, and then substitute, we get infinity over infinity. So when you get infinity over infinity, apply L'Hopital's rule. Differentiate atas, differentiate bawah. Senang je. Okay, 1 over 3 exponent 3x. Substitute again, 0. 1 over infinity, 0. Okay, sama juga macam example 2, x ln x. 0 times negative infinity. So x ln x, limit x approach to 0, x ln x over 1. So dia transform. Ni dia transform je. Dia ganti ln x over 1 over x. Okay, so differentiate ln x. So again, awak kena tunjuk dulu infinity over infinity. Okay, barulah awak differentiate. 1 ln x equals to 1 over x. Differentiate 1 over x negative 1 over x square. And then simplify. 1 over x darab dengan negative x square. So cancel out, we get negative x. X substitute 0, 0. Okay, so example 3 pun sama. Infinity minus infinity. Okay, yang ni okay, digabung. Okay, didarab silang. Yang ni daripada sini ke sini didarab silang. Okay, sin x minus x over x sin x. And then 0 over 0. 0 over 0, differentiate sin x, cos x, x1. X sin x, dia guna product rule. Okay, dia guna product rule. Dia guna product rule, dapat sin x plus x cos x. Substitute 0 over 0. Again, you must differentiate. Sekali lagi. Negatif sin x, yang ni sin x cos x, product rule. Cos x minus x sin x. And then substitute x equals to 0, 0 over 2 equals to 0. Okay. So example 4 pun sama. Nampak tak? Okay. Example 4. infinity minus infinity, 0 over 0, differentiate sekali lagi, 0 over 0, and then substitute 9 over 2. Okay, next, 0 power 0, infinity power 0, 1 power infinity. Okay, so introduce a dependent variable y equals to fx power gx. Calculate the limit of ln y. Limit ln y equals to limit ln fx gx equals to limit gx ln fx. Okay, awak guna definition. Ni adalah definition. Okay, definition maknanya method dia ni. Okay, bila awak masuk ln gx ni, kita boleh jadi darab. Nampak tak? Gx bawa ke depan, gx ln fx. Okay, itu cara dia. Okay, so let y, example 7, limit x equal to 0, 1 plus x power 1 over x. If you substitute x equal to 0, 1 power infinity. Okay, so how to solve this? Let y, and then limit ln y. Left hand side ln, and then right hand side you must put ln. Okay, when ln, bila dah ada ln, 1 over x ni jadi darab. Okay, nampak tak? Okay, so substitute 0 over 0, and then differentiate ln 1 plus x, 1 over 1 plus x. Differentiate x, 1. Substitute 0, 1. Okay, 1. So 1 ni, this is ln y equals to 1. So ln y equals to 1. So kita nak y kan? So masukkan exponent. Exponent ln y equals to exponent 1. So they cancel. We get y equals to exponent 1. So the answer is y equals to exponent. Okay, nampak tak? Oh, tak nampak. Y equals to exponent. Okay, exponent ln y equals to exponent 1. Cancel exponent dengan ln ni, kita cancel. Y equals to exponent. Okay, sama dengan example 8. Okay, dia punya solution dia. Okay, and then tutorial 19.